This video is on work, which is defined as force times distance, and here I have a spherical tank that's half filled with water, and I want to find the work done in pumping the water out over the top of the sphere. So here's the spherical tank that's half filled with water again, and so to find the work done in pumping the water out over the top of the sphere, what I'm going to do is I'm going to slice this water right here into 10 slices like this. And then we'll find the work that's needed to lift each slice of water to the top. And so the sphere has a radius of 10. And so for this slice number 1, the bottom of the slice is on the ground. And then the top of the slice here is at y equal to 1. And so I'm going to use the midpoint right here, which is 0.5, as the distance from the ground for slice number 1. And therefore the distance from the 0.5 here to the center of the sphere is 9.5. And then the distance from the 0.5 to the top of the sphere would be 19.5. And then what we need is the volume of this slice right here, which is a cylinder. And so we need the radius of this slice. And so the radius is right here. So right here, this is 9.5. And then the radius of the sphere is 10. And so let's call this x. So we have 9.5 squared plus x squared equal to 10 squared. So x is equal to 3.1225. So the radius of the disk is 3.1225. The thickness of this disk is 1. So the volume will be 30.63.05. And so the weight of slice number 1 is 62.5. Here we're making the assumption that water weighs 62.5 pounds per cubic foot. And so the weight for slice number 1 is 1914.4. And therefore the work done in lifting the slice here to the top of this water tank will be the 1914.4 times the distance. And so the distance from here to here is 19.5. And so we'll get 37,330. And here's slice number 2. The bottom of the slice of this slice number 2 is I add a distance of 1 from the ground. The top of the slice is at a distance of 2 from the ground. And again, I'm going to use the midpoint, which is 1.5, as the distance from the ground for slice number 2. And so the distance from 1.5 to the center of the sphere is 8.5, and the distance from the 1.5 to the top of the sphere is 18.5. We need the radius of this slice number 2 in order to figure out the volume of this slice number 2. And so once again, the distance from here to here is 8.5, and then from here to here, which is the radius of the sphere, which is 10. And then again, call this x right here. So we get 8.5 squared plus x squared plus 10 squared. And then x is 5.2678. The thickness of the slice again is 1, so the volume be 87.17. And so the weight would be 62.5 times 87.17, which is 5,448.7. And so to lift this slice here to the top of the sphere, the work is going to be 5,448.7 times 18.5, which is 100,800. That's which is the foot-pounds for slice number 2. And for slice number 3, the work is 150,330 foot-pounds. Slice number 4, work is 187,906 as 96. For slice number 5, work is 212,278 foot-pounds. Slice number 6, work is 227,053 foot-pounds. For slice number 7, work is 232,600 foot-pounds. Slice number 8, work 230,097 foot-pounds. Slice number 9, work is 220,721. And slice number 10, work is 205,651 foot-pounds. And so here, once again, this is the work for each slice of water. And so the total work will be 1,803,961 foot-pounds. And so this number right here comes when we divide this water here into 10 slices. And so we want the exact answer, then we need to divide it into an infinite number of slices. And if we divide this water right here, this half of the tank here, half of the sphere here, into an infinite number of slices, then this is one of the slices of water here. Let's call this the ith slice. And so for this slice right here, the distance from the ground, let's call it y sub I star. And therefore the distance from here to the center of the sphere would be 10 minus y sub I star. And then the distance from the here to the top of the tank will be 20 minus y sub I star. And now let's figure out what the volume and the weight of this ith slice is. So the distance from here to here is from the middle of the disk right here to the ground is y sub I star. And so the distance from here to here, from the center of the sphere to the center of the disk, is 10 minus y sub I star. And then if we look at this right triangle right here, and this is 10, which is the radius of the sphere, and let's call this right here, let's call this x sub I, which is the distance from the from the middle right here, from the center here, to the sphere, to the surface of the sphere. It's going to be, let's call it x sub I. And so we have x sub I squared plus 10 minus y sub I star squared equal to 10 squared, for this right triangle right here. So we have x sub I squared is equal to 100 minus 10 minus y sub I star squared. The weight of this disk right here is going to be the 62.5 times the volume of this disk. And the volume is going to be pi times the radius squared, which is x sub I right here, squared, and then times the thickness of the slice. And we're going to make all slices have the same thickness. And let's call it delta y. And so x sub I squared is 100 minus 10 minus y sub I star squared. And then the delta y, or the thickness. And then simplify here, we'll get 62.5 pi times 20 uh, y sub I star minus y sub I star squared, and then delta y. And so this is the weight of this ith disk. And so the work that's needed to lift it to the top of the tank, and then we just multiply the weight by the distance. And so the distance from here to here is 20 minus y sub I star. And then simplify, then we'll end up with this. And so that's for the ith disk. And now we need the work. We need to find the work to empty the entire tank. And so we need to, we have an infinite number of slices. The work for an infinite number of slices would be this. So this is work for the ith slice. This is work for an infinite number of slices of water. And again, when just like before, when this limit here exists, then we defined it as the integral from 0 to 10, 0 to 10, and then the 400y minus 40y squared plus y to the third, and then dy. And then the integral would be 200y squared minus 40y to the third dividing by 3 plus y to the fourth dividing by 4. And evaluating from 0 to 10, we end up with 1,799,870,000.79 foot-pounds. And recorded when I divided this water here into 10 slices, then and we found the work for each slice. Then the total work was 1,803,961. So this is for 10 slices, and this is for an infinite number of slices. We can see that they're very, very close. And that's the end of the video.